Welcome, Divinio.
Good evening. I'm James Fry, CEO of Divinio. This is Brian Fry, no relation, the data scientist at Divinio. I'm really excited to be here on the 100th event. It's been a desire to present here for a long time, so here we are. Divinio has a powerful wireless IoT ML-enabled sensor platform for real-time data analysis and for use in sports and also industrial IoT. All contained here. We'll get to that in a little second. What's the problem with IoT today? Everyone is chasing the pot of gold at the end of the IoT rainbow. But if you look at data from various respected outlets like Global Data and Cisco, they're going to show you that IT decision makers have only 35% of them are happy with the outcome of IoT projects. On the business side of the house, it's only 15%. So it shows you there's a disconnect between business and the IoT side of the house. Why? Why do 85% of these projects fail? Well, they have problems with installation, they have problems with connectivity, problems with collecting the data, and obviously the cost. I spoke to a CEO of a structural vibration integrator the other day, and he told me that if he could bring down the cost by 3x, he would be able to increase his market penetration by 10x. So that's one of the challenges right now. A single edge device can stream 8.3 gigabytes per day. So people are collecting enormous amounts of data, but they're not able to analyze that data in real time and use it to help their machine health. But it's going to be a $381 billion market by 2023. That's going from about 130 billion today. So there's a huge opportunity, and everyone wants a piece of this pie. So I've got a doppelganger in the room here. Welcome to the Sticky, the flexible sensor platform. This powerful sensor platform weighing less than 5 grams packs 9 different sensors. It's got vibration sensors, 3-axis gyro, accelerometer, has room for strain gauges, has a 5-year battery life in wait and listen mode and a 48-hour battery life ordinarily. Temperature, pressure, humidity sensors. It's FCC certified, CE certified, IC certified, IP65 certified, ready to roll in industrial IoT and sport today. And we'll get into some of those use cases. It's fully configurable, customizable, and has a powerful computer on board and a reasonable memory before we start taking data up to the cloud. The best demo you ever give is the one you don't give. So I'm going to take you through an example of how easy it is for us to simply, this will be double-sided adhesive. If you need a more robust industrial application, you can have that. Wow, I'm moving on the time here. Simply stick it to your machinery. Yeah, maybe I'll stand back. Stick it to the machinery. We press record. Oh, I've got an echo here. Press record, and I'm ready to start streaming data. Okay, here are my captured data signals. I can tap into this signal on the app. It'll give me an opportunity to change the capture settings and the trigger settings. So I can change the data rate up or down, period samples, threshold, window, boom, and I can start taking data again. People in plants are doing a lot of walk around stuff. It's very human intensive still. Our devices enable people to simply install it and then monitor and do predictive maintenance on their assets. And we can attach metadata to it. So you'll see on one of these capture signals, I've added some metadata, BNT100, and that helps us keep tabs on the data that we're collecting.
So I'll go quick here, but this is a high-level overview of using this platform to build a machine learning model. So what we're looking at here is we performed several hundred experiments where we impacted the ball on the cricket bat at known locations. And so we're building a model to look at the vibration signature coming off of these impacts and then output where along the long axis of the bat that impact occurred. And so if we go to the end first, so what we have there is saying, well, the x direction is the actual position, the y is where our model predicts. Perfect prediction would be a diagonal line. And so we come up with something that's actually quite good. And what we're doing here is, first, there's a lot going on, but we have from the raw time series data coming from this vibration information, we're extracting particular features, peak levels at certain frequencies and so forth. Then in the next step, we combine several of those into just 3 features that we feed into a machine learning model that actually works quite well. And so this is a very, very high level overview, but we have a Python SDK to help out with every stage of this process, including the visualization. So it really is not nearly as much work as you might think to get from this raw data to a working model.
Okay, we're going into overtime. Hopefully the Bruins don't tonight. So here's a very simple application. We were approached by a pump company that were looking to understand cavitation in their pumps. So when pressure changes in pumps, the vapor can create huge shock waves. So within 6 hours at arriving at the scene, we were able to instrument the pump, take data, look at interesting trends in the data, deploy some firmware back to the device and thereby be able to send an alarm or a routine check-in to the end user about the pump and whether there's cavitation or not. We started in cricket. One VC said to me, you chose the absolute hardest use case you possibly could have done. It's high visibility, high stakes. When a 100-mile-an-hour ball hits an 80-mile-an-hour bat coming at it, lots of things fail, and lots of things did fail, but we kind of worked through them all. We demoed this to Satya Nadella. And within seconds of seeing it, he invited us to Build 18 to demo it, and he asked us to be the first company in the world to put his Sphere chip into an edge device, which we did. And it was launched in October by Anil Kumble, a famous Indian cricketer, under license from us with Microsoft. So what Divinio is proposing to do is shorten the time of deploying sensors and data analysis for industrial IoT and sport. I'll be happy to give you a demo after all the presentations are over, and you can see how quickly we're sending data up to the cloud and back from the cricket application. Thank you very much. Questions? Yes.
What is your cloud interface? Is there like a cellular connection, or is it something in between?
So, do you want to take that one?
Sure. Yeah. So we have a Bluetooth connection from the sensor to an edge device, which in the demo we're showing is the phone, and then go to the cloud from there.
Yes.
How do you determine which kind of sensors to put on the edge device? Is there some sort of analysis that said those are sort of universal for most use cases?
Well, my co-founder, CTO, is not here today. He is an MIT grad and is an expert in piezo sensors. So a lot of the bedrock of our solution is formed from his academic expertise in that area. So yes, we have optimized some of that, but we can also configure it with end users who may have specific use cases and specific sensors they want to deploy in their devices.
So you could customize it with your sensors if it was needed?
Absolutely, yeah, fully customizable and configurable to end users. Not for free, but yeah.
And just to add to that, the low-level control of the ADC is available to you, so you can change the sampling rate, you can change gains, and so forth.
Yes.
How does your device know when to start taking measurements if you first have to train something, decide when is important data?
Good question.
Sure. So if we're running in a finite mode where we're just acquiring individual bursts of data, they're basically it is monitoring levels all the time, and then you can set a threshold where, so if we're looking at impacts, then when there's one event that exceeds some particular level, then you take X amount of data before as well as after that event.
32 seconds left. Hello? Yeah.
They always say that the edge device is smart, but all the smart work is being put to the cloud. So, and the novelty is that some of that has to be put back into the edge so that training, like for example, the inference can be faster, training can be put back to the cloud. So do you use that hybrid approach of balancing the work between the edge device and the cloud?
Yeah, I mean, the beauty of this platform is that we can decide and optimize where we do the analysis, whether it's on the device itself, the edge device, or in the cloud. So that's something we've optimized for Cricket, but we would work with end users to find out where they need to do it based on their concerns around security or other issues. Yeah. Thank you, guys.